Okay, this part is a little bit trickier than the first part, than the single lens system. What you're going to do is you're going to take your screen, you're going to put it down here, down towards the end of the optical bench. Then you're going to take your big lens, that's your object lens. We call it that because it's going to create the object for the second lens in our two-lens system. And you're going to find a point where you find the image, that you find a clear image. Then you're going to take your test lens and you're going to put it somewhere in between these two, in between the object lens and the screen. Then you move the screen, and you might need to move the test lens too, until you find a point where you get a clear image of that object, of the screw from the light bulb. Now, do not move the object lens. Because if you move that, then you're moving the position of your virtual object. This first lens is creating an object for your second lens. So don't move that first lens. And then also, make sure that the image that you find isn't in the same position where you found it before. Because the object lens is bigger than the test lens, you're going to get some light rays that will travel out here that will be unaffected by the test lens. So there will be a place where you'll be able to find your first image, which you found without the test lens being in the optical axis, where that's not the image that you're looking for. So you actually find that there are two images. Make sure that your screen is not here where you found your first one. You record the various positions, and your lab manual tells you to record the large lens position and the test lens position, and where the object is from your first lens, and then where the image is for the second lens. So record those various positions. I find that it's useful to draw a diagram for this, and using those positions, label the different distances that I have. As we talked about in the theory section, that this, you'll have an image right here. I'm going to call this Q1. I'm just going to draw a whole separate diagram, actually. So here is my first lens. Here's my object. I create some image right here. This is P1. This is Q1. Then I put my other lens in right here. Now this distance becomes the object distance, T2. And then I find some new image distance. I think it's in between here. I'm not sure where it is exactly. But this is now Q2. Okay? I find it useful to draw this diagram out to help you keep track of all the various P's and Q's, to mind your P's and Q's. Don't forget, too, that this object distance, because it's a virtual object, that it has a negative value. When we're talking in optics, negatives always tell us that this thing is in some virtual space. That virtual images have a negative image distance. Virtual objects have a negative image distance, that they're in the virtual space of that optical system, and that's why they have a negative value. As I said, this is a trickier part. Your instructor will be there to help you if you have any questions, but you'll have to play around with the lenses to actually see where these various images are. It's the fun part too, I think.